Hi dear students, welcome to Geeta's classes. In this class, we are going to discuss some multiple choice questions on the topics graph theory and recurrence relation. Actually, I am not going to give you the choices. I will explain the answers without choices only, so that if you get choices, then it will be easy for you. Okay. So a graph is a collection of vertices and edges. Actually, generally we represent G as a vertex set and edge set. This is the graph, okay, representation. A graph with no edges, if you have only vertices, you may have one vertex or two vertex and three vertices, etc. What is it called? Null graph. Null graph or trivial graph also, okay. A graph G is called a dash if it is a connected and acyclic graph. Then it is called, this is the definition of a tree. A tree is a connected acyclic graph. It will not contain any cycle. The degree of any vertex of a graph G is the number of edges incident with the vertex. Incident with it. Okay. So number of edges incident with the vertex. Suppose if you have A, B, C, D. What is the degree of A? 1. Degree of B? 1, 2, 3. You have to count the number of edges incident with the vertex. So 1, 2, 3. So degree of B is 3. Degree of C is 1, 2. Degree of D is also 2. Okay. The vertex of a graph G is called even or odd depending on the degree of the vertex. Degree of the vertex is even or odd. Okay. So if the degree is even, the vertex is called even vertex. If the degree of the vertex is odd, then it is called odd vertex. A circle has no vertices. It will not contain any vertex. The number of edges of the root of the node is called the height of the. Actually, I have given this answer. Height is the answer. Okay. So if you have a graph like this, A, B, C, D, E, F, G and H. Actually, height means height of F is 2. 1, 2. Height of H from the root. This is the root. Okay, this is the root of the tree. From the root, how many edges you have to travel? 1. If height of H means 1, 2, 3. Height of G is also 3 and so on. And the maximum height is always called the depth of the tree. Okay. Next is the number of infinite regions of a connected planar graph. If you have one vertex and one loop, here R1, R2. If you have three vertices like this, then R1, R2. If you have R1, R2, R3. So in the first graph, R2 is the infinite region. Second graph is also R2 is the infinite region. Here in the third graph, R3 is the infinite region. For any planar graph, you will have only one infinite region. Okay, even if you have a null graph with one vertex, then infinite region will be there. Okay, only one, always there will be one infinite region. The maximum degree of any vertex in a simple graph. Simple graph means what? It will not contain any loop or parallel edges. It is always n minus 1. So it can have a maximum of n minus 1 degree. Okay, n minus 1 edges can be incident with any vertex. So maximum is n minus 1. The vertex whose removal disconnects the graph is called cut vertex. Similarly, if the edge is removed and if it is increasing the removal of vertex disconnects, you can say, or increases the number of components also means the same. So if the edge is removed and the number of components is increased, then it is called cut edge. And if the minimum number of edges which are to be removed to increase the number of components, it is called cut set. Now, if G is a simple connected planar graph with 6 vertices and 8 edges, then the number of regions is, actually we have Euler's formula. What is Euler's formula? It says that V minus E plus R is equal to 2. Number of vertices minus number of edges plus number of regions is always 2. Okay. So here vertices is given 6, edges given as 8 plus R is equal to 2. That is minus 2 plus R is equal to 2 implies R is equal to 2 plus 2, it is 4. So 4 is the answer. Now the degree sequence of the following graphs. How will you find out the degree sequence? You find out the degree of all the vertices and write them in ascending order. Very simple. Degree sequence is the number of degrees of all the vertices written in ascending order. That is called the degree sequence. So for the first graph, it is 1, here you have 7 vertices. So the 7 numbers should be written in ascending order. Similarly, for the second graph, you have 6 vertices. So all the degrees of all these vertices should be written in the ascending order. Okay, that is the degree sequence. And if you find out for any graph, the number of odd degree, here if possible draw the graph with the degree sequence 1, 1, 2, 3, 4 or give the proper reason for not drawing. So here also you can check in the previous question also. Any graph, for any graph actually the number of odd degree vertices, the number of, this is the property of the graph, the number of odd degree vertices is always even. Number of odd degree vertices is even. So here number of odd degree, which are the odd degree vertices? A, B, C, D, E. So A is having odd degree, B is having odd degree, D is having odd degree. So how many vertices are there? 1, 2, 3. 3 is not even number, right? So the number of odd degree vertices, if it is odd, you cannot draw a graph like that. The property of the graph is, for any graph, the number of odd degree vertices should be even. That is the property. Therefore, we cannot draw this. So it is not possible to draw the graph. Okay. Here the number of odd degree vertices is 3. Which is not even, therefore it is not possible. You have to write the reason like that. Now solution of recurrence relation. So T of n is equal to T of n minus 1 plus n. This is the recurrence relation. What do you mean by solving this recurrence relation or finding the solution? You have to find out an explicit function of n for T of n which satisfies this relation. So T of n minus 1, this is given as n minus 1 plus n. So this can be written as T of n minus 2 plus n minus 1 plus n, etc. If you write like this, in general, I can write n minus k plus etc. plus n minus of k minus 1 plus etc. plus n minus 1 plus n. I want this n minus k. So n minus k, actually what is given? T of 1. Okay. And I have explained all these problems or these methods in a separate classes of recurrence relation. Please go through them. So T of 1 is equal to 1. So n minus k. I want to make this as 1. T of 1. Okay. So n minus k is 1. Therefore k is equal to n minus 1. So this is T of n minus 1 plus 2 plus etc. plus n minus 1 plus n. That is, this is n and n will get cancelled. T of 1. T of 1 is given as 1. So 1 plus 2 plus etc. plus n minus 1 plus n. That is the sum of first positive n integers. So n into n plus 1 by 2 is the answer. This is a university question. Last time or year before last, they have asked. The same question was asked in the question paper. University question. Okay. So next is the value of A2 for the recurrence relation AN is equal to. What is given? A0 is given. Just substitute. So A1 is equal to 17 into A0 plus 30 into N means whatever is here you have to write. Here A1. So 30 into 1. That is equal to 17 into A0 is 3 plus 30. That is 51 plus 30 which is equal to 81. Okay. So A2 is equal to 17 A1 plus 30 into n. N is here n is 2. So into 2. So 17 into 81 plus 30 into 2, it is 60. That is equal to 1377 plus 60, that is 1437. That is the answer. Next one, the recurrence relation for Tower of Hanoi problem is, Tower of Hanoi problem, separate class I have explained. Please go through that for understanding the Tower of Hanoi problem. Okay. The relation is an is equal to 2an minus 1 plus 1. Okay. And the solution is 2 power n minus 1 is the solution for Tower of Hanoi problem. And a sequence is defined by the relation un plus 1 is equal to 13 un plus 1 with u naught is equal to 5. Okay, so u naught is 5 is given. So u1 you can find out as 13 into u naught plus 1. That is 13 into 5 plus 1. It is 66. 65 plus 1, 66. Similarly, u2 is equal to 13 u1 plus 1. That is 13 into 66 plus 1. That is 859. And u3 is 13 into u2 plus 1. So the answer here is 1168. Therefore, u1 plus u2 plus u3. If you add all the three numbers, you will be getting 12093. This is the answer. Okay. Next is the chromatic number of the cycle graph Cn. Chromatic number means what? It is color. It is coming in the graph coloring. Graph coloring means you can assign the colors, different colors to the vertices, so that no two adjacent vertices have the same color. Okay. So for example, C3 if you consider, if I assign color 1 for this, I cannot assign 1 for this. So I have to assign 2. Now I have to introduce another color 3. Okay. No two adjacent vertices should have the same color. And if it is even, so 1, 2, I can assign 1 here because it is different colors. 1 and 1, they are not adjacent. I can assign 2. Similarly, you can check for odd number of vertices. So chi, this is the symbol for chromatic number. So chi of Cn, that is chromatic number of the cyclic graph, is 2 if n is even and 3 if n is odd. This is the chromatic number. Okay. Then chromatic number of the complete graph Kn. Kn means what? Kn is the complete graph. Complete graph means for every vertex it is adjacent to all the remaining n minus 1 vertices. So if you assign one vertex one color, all the remaining n minus 1 vertices should be assigned different assigned n minus 1 different colors. So the chromatic number of Kn is n. So n different colors should be assigned. Okay. Then only it is called proper coloring. Then given that a0 is equal to 1 and an is equal to n plus minus 1 the whole power n into n minus 1 for n greater than or equal to 1. What is the value of a4? So I have already told you a1 means 1, the same value a1, and minus 1 power 1, so minus a0. So 1 minus 1, it is 0. Similarly a2 is 2 minus of minus 1, sorry, plus minus 1 the whole square, so it will become plus a1. That is 2 plus 0, which is 2. Similarly, if you a3, if you find out 3 minus a2, minus 1 power 3, that is a2 minus a2. So 3 minus 2, which is 1. And a4, 4 minus of minus power 1, sorry, minus 1 power 4 is plus 1, so plus a3, that is 4 plus 1, which is 5. a4 is asked, a4 is equal to 5. And the solution of the recurrence relation an is equal to an minus 1 plus 2n with the initial term a0 is equal to 2. So here the shortcut is you have to substitute n is equal to 0 and check whether you are getting a0 is equal to 2 or not. If you substitute n is equal to 0, an is what? A0 you should get, it is 7. So it is not satisfying. So first is not the answer. Here 5 by 2, it is not the answer. 2 into 1 plus 0, that is 2 into 1, it is 2. This is correct. Even this is also not satisfying. Okay, n is equal to 0 means 0. So only C is the answer. C is the correct option. Next is the order of the recurrence relation. Order of the recurrence relation is the difference between the maximum and highest and lowest subscript. So n minus of n minus 3. Here the highest value of the subscript is n. Lowest subscript is n minus 3. So n minus of order is equal to n minus of n minus 3. So n minus n plus 3. n will get cancelled. You will be getting 3. So Euler's formula for a simple connected planar graph is V minus E plus R is equal to 2. The number of vertices minus number of edges plus number of regions is equal to 2. Then state the fundamental theorem of graph theory. Fundamental theorem states that already you have studied this as a formula, or handshaking theorem also, we call it as handshaking theorem also. The number of degree of all vertices is equal to sum of degree of all vertices is equal to twice the number of edges, because every edge it will give one count for each vertex. Suppose E is A, for A counting the degree of A, we will count this E once, and for B also it is contributing 1. Okay, therefore the sum of degree of all the vertices will be equal to twice the number of edges. Okay. Give one example of a wheel graph. Wheel graph means what? In the cycle graph, if you first you draw the cycle graph, and in the middle you assign one more vertex you introduce, then join all the vertices. Okay. This is W5. Okay. So if you have W4, this is W4. C3 you draw, then this is W4. Okay, this is the wheel graph. And the number of vertices in a spanning tree of a graph. Spanning means what? It should contain all the vertices of the given graph. So the number of vertices in a spanning tree of a graph is equal to the number of vertices in the graph. Number of vertices of the graph, or in the graph. If it contains all the vertices, then only we call it as a spanning tree. Okay. Then a bipartite graph cannot have a what? Loop. Actually bipartite means like this. Actually this one V1 you can join. Any edge if you consider, okay. Here you have V1 A, B, C, D, E. I should be able to, V is equal to what? A, B, C, D, E. If you can divide the vertex set as A, B, and V2 is equal to C, D, E. Now any edge if you consider E1, it joins one vertex from the first set, another vertex from the second set. If you consider BC, B is from V1, C is from V2, and so on. So if it has a loop, definitely it will join the same vertex in the frames from the same set, right? Therefore it cannot have a loop. Okay? Bipartite graph cannot have a loop. And draw the undirected graph for the matrix 0, 1, 0, 1, 1. This is a representation, matrix representation for the graph is given. You are asked to draw the undirected graph. So let us assume that V1, V2, V3. There are it is a 3 by 3 matrix. So it contains 3 vertices. So V1, then V2, and let us say V3. So V1 and V1, there is no loop. V1 and V2, yes, there is an edge. If there is an edge, it will be 1. If there is no edge between the vertices, then it is 0. So V1, V3, no, they are not joined. V2, V1 already we have joined because it is undirected, whether it is V1, V2 or V2, V1, it is the same. V2, V2 we have, so one loop you have to write. Okay. Then V2, V3, there is an edge. And V3, V2, yes, there is an edge. Here you have V2, V3, there are 2. So you have to draw like this. There are 2 edges. So 2 edges means we'll write 2. So this is the required graph. Okay. So hope this will be useful for you. Please give a like for the class and share it with your friends so that it will be useful for them. Thank you so much for listening.